Okay, so for our topic for today is regarding kinetics of a particle. So we have here the analysis of a particle. So here we are going to analyze the accelerated motion of a particle using the equation of motion with different coordinate systems. So depende yun sa motion ng ating given body or particle sa ating system na binigay. So we're going to use here the Newton's second law of motion or law of acceleration, in which it states that the unbalanced force on a particle causes it to accelerate. It has an acceleration in line and directly proportional to the resultant of the forces acting on the particle. So now, if we will consider a particle of weight W, so pag sinabing weight, that is always directly going downward. And if this particle is acted by forces, sabihin natin vector A, vector force A, and meron din tayong vector force B dyan. And then if we are going to analyze the resultant of these three forces acting on the particle, and then nalaman natin na nandyan mismo yung direction ng resultant natin. No? And kapag kinuha natin mismo yung value ng resultant at may value tayong nakuha, therefore, we can assume na yung system natin o yung particle natin is in unbalanced condition. It is not in equilibrium. Therefore, the particle is moving. No, moving in line or into the direction of the resultant. So, ibig sabihin, kapag nandyan mismo yung resultant natin, nandyan din mismo yung motion, nandyan yung acceleration ng ating particle. No? So, kapag yung resultant naman na nakuha natin is equivalent to 0, therefore, the particle is not moving. It is in equilibrium, a static equilibrium, where it is not moving. No? And then, sabi doon, acceleration is directly proportional to the resultant. Therefore, by that, we can say that R is proportional to acceleration A. No? And to make this expression into equation, R is equivalent to, maglalagay lang tayo dyan ng proportionality constant K. And that is multiplied by acceleration. No? Assuming the same body. Yung assume natin body dyan, assume natin yung body na yon with the same weight ay nasa vacuum system natin. No, pag sinabing yung particle ay nasa vacuum, nasa free space siya wherein there is no any matter that will act on the particle. No, ibig sabihin kapag i-drawing natin yung free body diagram natin ng particle na nasa vacuum, ang nag-act lang doon ay yung weight ng ating particle. No, na kapag kinuha natin mismo yung resultant, yun na din yung value ng ating weight. Diba? Siyempre, isang force lang yun nandyan, therefore, yun na rin yung value ng resultant natin. And that is going downward. No, sabi natin kanina, Newton's second law of motion, kung nasan mismo yung direction ng resultant natin, nandun din yung direction ng motion. At nandun din yung acceleration natin. Gets po? And then, for this particle, it is traveling vertically. No, therefore, acceleration is due to gravity. No, again, resultant is directly proportional to the acceleration. But the resultant is equivalent to the weight of particle. Gawin nating equal sign, maglalagay tayo dyan ng proportionality constant, K, multiplied by acceleration, and that is due to gravity. No? So, kunin natin value ng K natin, divide both side by G, that is W over G. Substitute now the value of proportionality constant K into this equation. Therefore, we can say that the resultant is equivalent to K, which is W over G multiplied by acceleration. Yan na mismo yung ating second law of motion. No, the resultant force acting on the particle or body is equivalent to W over G, or that is the mass of the particle multiplied by the acceleration. Which is parehas lang siya dyan. No? And then, by virtue of the third law of motion ni Newton, ang sabi doon kay third law, law of action and reaction. For every action force, For every action force acting on a body or particle, there is an equivalent reaction force. So kung i-consider natin formula ito, for every action force which is the resultant or the effective force on the particle, there is an equivalent reaction which is the reverse effective force or the inertia force. So yung tawag natin dito kay WA over G is the reverse effective force or the inertia force. No. Ang tawag naman natin dito kay action force is what we call the resultant or the effective force. Nagets po ba? And that reverse effective force is opposing the resultant position or direction. Kung nandiyan mismo yung resultant natin, reverse effective force or inertia force is opposing the direction. Nandiyan siya mismo. Nagets po ba? So now, we have here, so iikot lang tayo dun sa formulang yun. So we have here D'Alembert's principle. So, D'Alembert's principle, usually gagamit mismo ito kapag yung ina-analyze natin is a system or a body or a system of particles. So, D'Alembert's principle states that the resultant of the external forces applied to a body composed of a system of particles is equivalent to the vector summation of the effective force on each particle of the body. So, assume natin ito yung body natin. And that body is composed of many particles. Assume natin yung mga particles natin. No. And that body is acted by the external forces. So, assume natin that is external force A and then external force B. Then, kukompute natin yung resultant natin. Assume natin nandyan yung resultant natin. At kapag nandyan yung resultant natin, nandyan din mismo yung ating motion. No, in line with the resultant, yung ating acceleration o yung motion ng ating particle. And then, meron yung weight, syempre. Ito yung centroid ng ating body, nandyan yung ating weight ng ating body. Syempre, yung mga particle na nagko-compose mismo sa body, may kanya-kanyang weight din, no? So, particle 1 is weight 1, particle 2, weight 2, particle 3, weight 3. By the D'Alembert's principle, sabi doon, the resultant of the external forces A and B, or that is vector A plus vector B, that is equivalent to R, is equivalent to the vector summation of effective forces on each particle. Sana ba yung ating effective force about particle natin? That is W A over G. Summation for the particles. No, see sa figure natin meron tayong tatlo, therefore, that is W1 A1 over G plus W2 A2 over G plus W3 A3 over G. Kapag mas maraming particle pa yan, that is and so on. No? Or, it can be represented by the total weight of the body. And that is total weight equivalent to the acceleration over G. So, eto, parehas lang mismo dito. No? Eto, mas gamit lang kapag iisang body or particle yung ina-analyze sa system natin. Ito naman mas gamit kapag madami ng body or particle sa isang system mismo na ina-analyze natin. No? And then we have here equation of motion. So, paano mag-consider mismo ng equilibrium for a given body that is having a acceleration or equilibrium of accelerated bodies. So, when more than one force acts on a particle, the resultant force is determined by a vector summation of all the forces. And we already studied that regarding sa ating statics of rigid bodies. Yung resultant force that is, or that can be determined using analytical method or graphical method. Alam na natin kung paano gawin yun. And for this more general case, the equation of motion may be written as considering that the motion is with respect to our x-axis. So, eto mismong mga formulas dito na nakalagay, we consider na yung ating motion ay nasa iisang dimension. No? Na kay x lang, na kay y, or na kay z. For these equations, na kay x-axis yung motion. At iisa lang. No? Kapag naka-X yung motion natin, nandun yung ating reverse effective force. No? Dahil kapag walang reverse effective force yun, gagalaw at gagalaw yun. Kumbaga, hindi siya naka-equilibrium system. Gagalaw at gagalaw kasi nga we're considering the motion, but then hindi siya nasa equilibrium kapag hindi natin na-consider yung reverse effective force. So, if we are going to analyze dynamic equilibrium, dapat ma-consider natin mismo yung reverse effective force natin kay equation of motion. Assuming na nasa x-axis yung motion, therefore, nandun yung ating reverse effective force. And then, summation of force along y and then z will become 0 or equivalent to 0. Kapag nakay vertical yung motion natin, ng body natin tsaka particle, yung summation of force along y, nandito yung reverse effective force natin na WA over G. And summation of forces along X and then Z will become equivalent to 0. Same kay Z. Kapag naka-Z axis yung motion, nandito yung reverse effective force. And this will become equivalent to 0. Paano naman kapag dalawang dimension yung motion? Kunyari, it travels. Kunyari, ito yung system natin. This is X. This is Y. This is Z. Yan pa ganyan. It travels along X and then Z axis. Therefore, yung summation of vertical force natin or summation of force along Y axis is equivalent to 0. Yung reverse effective force natin nakay X and nakay Z. Dahil dalawang motion. But then, magiging equation natin is summation of forces along X equivalent to W AX over G. Ito naman, summation of force along Z is WAZ over G. We will use the component along the axis of their motion. No. Ito naman magiging 0. Pero kapag 3-dimension yung motion, itong summation of y is equivalent also to WAY over G. No. So, titingnan natin palagi mismo kung ilan yung motion na kino-consider. Kung ilang axis yung motion natin. Pag iisa lang, we can use this equation and then titingnan nyo mismo kung nasan yung axis. Para alam nyo mismo kung ano yung naka-equal mismo sa equation natin. Equivalent ba siya kay 0 or equivalent ba siya kay reverse effective force? No? So, usually, sanay na kayo dyan dahil for static equilibrium, naka-equal lang tayo kay 0. Dito, may nadagdag lang na reverse effective force or inertia force sa ating equations of motion. And we have here the general plan for the solution of the problems na kino-consider natin mismo. No, first one is to draw the free body diagram for each body involved in the problem. So, alam nyo na mismo kung paano mag-drawing ng free body diagram. Indicate thereon all forces, both known and unknown, representing the latter part by an appropriate symbol. If the direction of any unknown, except for bodies or particle na subjected to friction force, is incorrectly assumed, the solution will yield its correct magnitude but with negative sign. Friction forces must always be directed to oppose the motion. But then kapag yung motion o yung body mismo or particle na kino-consider natin is subjected to a given surface, meron tayong friction force doon. Kapag nakuha natin mismo yung value ng kanilang motion or acceleration at naging negative, incorrect yung magnitude, incorrect yung direction. No. But then for this definition, kapag yung body natin ay hindi hindi siya in contact with a given surface, wala tayong friction force doon. Therefore, yung makukuha nating value doon, kahit na nag-yield to a negative value, yung magnitude doon ay parehas lang. Ibig sabihin ng negative sign, mali tayo ng assumption for the direction of the given body. No? And then number 2, determine the direction of motion, if not evident or specified, and indicate it by a dash arrow near each free body diagram. No, usually lang ginagawa natin dito kapag evident nor specified, solid line, yung solid arrow yung ating kino-consider. And then, kapag hindi evident ba or specified, ginagamit natin yung dash arrow. No, para hindi tayo malito kung nag-assume ba tayo or hindi. And then number 3, determine the kinematic relations between the bodies involved in the problem. Eto mismo, pwede nating i-skip yung number 3 step kapag yung body na kinoconsider ay isa. Pero pag 2 or more than bodies yung kinoconsider, we need to relate their kinematics. No? Ano ba yung relationship ng kanilang distance or displacement? No? Ano ba yung relationship ng mga bodies na yon with respect to their velocities? And then, ano yung relationship ng kanilang mga acceleration? That is kinematic relations. No? And then, apply the equation of motion. Dito na tayo susunod, o gagamit ng susunod na step. We will use these equations. And then, number 5, solve for the unknown using such additional equations of kinematics. So, na-discuss na natin for our first topic. Equations of kinematics, meron tayong 3 doon. 4, pati yung constant velocity. But then, pag sinabi mismong kinetics, yung equations of kinematics na involved doon is constant acceleration motion. Dahil, we will assume na yung body natin dito or particle is traveling in a constant acceleration motion. Kapag hindi ni-specify sa problem, i-assume natin that it is in a constant acceleration manner. No? And that is to determine the relations between their position, velocity, and time. Also with their acceleration. So, problem solving lang tayo dito, guys. Ito lang yung madagdag sa ating ginagawa noon kay statics, yung reverse effective force natin. At para mas maintindihan natin, take tayo ng problems dito. We have here an elevator weighing 3,220 pounds from rest and acquires an upward velocity of 600 feet per minute in a distance of 20 feet. If the acceleration is constant, what is the tension in the elevator cable? So, drawing muna natin yung free body diagram natin. Meron tayong elevator. And then, may nakakonekta dyan na cable. And that cable will always emit a tension force. No, pag sinabi natin tension, that is going away from the given body. And then, meron tayong weight of the elevator. Pag sinabing weight, that is always directly going downward. No, yan na yung free body diagram natin. Meron lang tayong dalawang force na nag-act. No. And then, evident by motion natin, sabi doon, it has an upward motion. Therefore, solid arrow natin, acceleration is, wala pa, hindi pa binigay. But then, alam natin yung motion. Now, if we will consider summation of forces along x, sa horizontal axis natin, wala naman tayong force doon, di ba? At wala doon yung motion. Therefore, equivalent yan kay 0. No. So, hindi na naman natin magagamit yan dahil wala naman tayong kino-consider na horizontal forces. Now, if we will consider summation of force along y, that will be equivalent to reverse effective force. Bakit? Dahil vertical yung motion. Kung nasa yung motion, nandun yung ating reverse effective force. And that is equivalent to WA over G. No? Kung nasa yung motion natin kapag pataas, lahat mismo ng pataas na forces ay positive. Lahat ng downward forces ay negative. According to the given motion. No, given direction of motion. Now, tension T is positive. Downward to magiging minus, equivalent to reverse effective force, WA over G. Tension T yung unknown. Weight is already given. G, that is constant. Kukunin na lang natin mismo yung acceleration ng ating body. Hindi pa binigay. But then, it is moving with a constant acceleration motion. So, yung mga parameters na binigay, it starts from rest. Therefore, initial is 0. And then, final velocity, 600 feet per minute. Tama? And then, convert lang natin into seconds. This is 1 minute is to 60 seconds. That is 600 divided by 60. Oops.
10.
That is 10 feet per seconds. And then distance traveled is 20 feet. And then we are going to analyze the acceleration. Using equations of motion, relating these four parameters, ano yung magagamit natin doon? You can use v squared minus, or kinematic equations. Ito mismo yun, di ba? You can use this formula to relate these four parameters. And that is v squared minus vo squared equivalent to 2 as. Vo squared, that is 0. Final velocity, that is 10 squared, equal to 2. Acceleration is unknown. Distance traveled is 20. So what is the acceleration? 100 divided by 40. 2.5. Tama?
2.5.
Feet per second square. At meron tayong acceleration, substitute the acceleration value to our equation. Tension T is unknown, WA over G. Lipat mo to sa kabila, magiging plus. No? So, substituting the given parameters, weight of the elevator is 3,220 multiplied by A, 2.5. Naka-feet per second square to, therefore G is 32.2. Plus weight, 3,220 pounds. Ano yung magiging value ng tension natin sa cable natin?
3,470 po.
3,470 pounds. And that will be the requirement of this
70
given
po.
problem. May nakalagay dyan na sagot to. So, tama naman po tayo. No. So, let's take another example. We have here problem number 2. A man weighing 161 pounds is in an elevator moving upward. So, motion is specified already with an acceleration of 8 feet per second square. So, what pressure does he exert on the floor of the elevator? And then what will be the pressure B if the elevator is going downward with the same acceleration, which is 8? So, letter A muna tayo. No? Assume natin ito yung floor ng elevator natin. At nandyan mismo nakatayo yung ating man. The man weighs, that is going downward, 161 pounds. And then what pressure does he exert? Pressure is perpendicular to the surface of the floor. That is P. So, meron tayong dalawang force na nag-act sa ating body mismo. No? Now, if you will consider here, summation of forces along vertical axis pa din. Along vertical, nandun yung motion natin, di ba? And then, in-specify sa problem. That is going upward. Where A is 8. No. Sa vertical summation na yan, ng mga forces, nandyan yung reverse effective force natin. Equivalent kay WA over G. And upward forces are positive. Ano yung mga upward? P. Ano yung mga downward? That is minus 161. Equivalent to the weight, 161 yon. Acceleration is given 8. G is 32.2. Lipat mo to sa kabila, magiging plus. What will be the value of pressure?
201.
201 pounds. No? Ito na yung sagot natin. Letter B. What will happen to the pressure value if the elevator is going downward? So, ganun pa rin yung free body diagram natin. The weight of the man is still 161 pounds. Meron tayong pressure dyan, which is perpendicular to the surface of the floor. Now, the motion of the elevator is going downward, and that is still 8 feet per second square. So, if we will consider summation of force along vertical axis equivalent to reverse effective force, ang downward forces natin ngayon ay positive according to the direction of the motion. No. So, 161 is positive. Force P is minus P. Dahil going upward siya. The weight is 161. Acceleration is still 8. Gravitational acceleration is 32.2. So, computing for the value of P, ito magiging positive siya dito. Ito, lipat mo to magiging minus. Ano yung value ng P natin? Dapat daw ay 121 pounds.
121 po.
Okay. So, tama naman yung nakuha nating sagot. No. So, that is problem number 2. Any questions, guys? Wala. So, let's consider another problem. Oops. Okay, we have to determine the acceleration of the body B. Hindi lang nakalagay yung body B. This is body B. And this is body A. Body A weighs 300 pounds. Body B weighs 200 pounds. It is included in the problem, guys, hindi lang po nakalagay. So we have to determine the acceleration of this body, assuming that the pulleys are frictionless and weightless. So kapag frictionless yan, tsaka weightless, hindi na natin i-consider yung free body diagram natin dyan. Pero kapag may friction sa pulleys natin, so alam na nyo naman mismo kung paano mag-free body diagram doon at paano mag-solve ng mga forces. No, regarding pulleys na merong friction. Diniscuss na yan sa inyong statics of rigid bodies. Okay, so ngayon, kaibahan nito, dalawa na yung body na kinoconsider natin. Kapag dalawa na yung body na kinoconsider, hindi dapat natin kaligtaan yung step number 3 natin. Kanina, iisang body lang kasi. No, wherein, kinakaligtaan natin mismo step number 3. No, yung relationship ng kinematics ng mga bodies. So, i-relate natin yung distance traveled ni body A sa distance traveled ni body B. I-relate natin yung velocity ni body A sa velocity ni body B at yung acceleration ni body A sa acceleration ni body B. No? So, para ma-relate natin yon, gawin na natin yun para tuloy-tuloy na tayo mamaya sa pagsisolve. So, to relate, tingnan nyo to. Kapag tumaas mismo yung body B, bababa yung body A, di ba? Pero hindi natin alam yung distance traveled nila. Pero kung i-assume natin 10 feet mismo, tataas ng 10 feet yung body B. No? So, tataas yung ating cord o yung cable dyan. And then, bababa dito. But then, sa part na to, yung 10 feet na yon tataas yung kalahati. No? So, along this part, bababa yung 5 feet and then tataas yung 5 feet. Therefore, we can assume na yung distance traveled ni body A is 5 feet. Kapag nag-travel mismo ng 10 feet si body B, magta-travel mismo si body A ng 5 feet. Therefore, we can assume that distance traveled of body B is twice distance traveled of body A. Nagets po ba yun, guys? Pag di naintindihan yun, another solution, we can use the summation of work done by the two bodies. And that should be equivalent to 0. Or, work done by A plus work done by B is equivalent to 0. And we already knew that work is the product of force multiplied by the distance traveled of each body. So, plus force times distance of body B equivalent to 0. No? Okay, now, analyze natin yung tension sa bawat cable. May cable dyan, action and reaction, yung tension natin. Assume natin tension T yan. Iisang kable ito, di ba? Tuloy-tuloy lang yan. Since frictionless tsaka weightless to, therefore, kung tension T ito, tension T dapat din to. And then, tension T rin dapat mismo ito. Dahil iisang kable lang yan. Pero kapag may friction na yung pulley natin, mag-iiba na yung value ng bawat tension natin. No? And then, eto naman mismo, this is a cord connecting body A. Tama? So, meron din tayong tension dyan. Now, for this part or for this pulley, for that pulley to be in equilibrium, meron tayong tension T dyan, tension T. Ito yung tension connecting body A. For this pulley to be in equilibrium, dapat 2T yun, di ba? Para maging equilibrium yung system natin. Therefore, yung tension cord dito ay 2T. No. So, balik tayo dito kay work done by each body. First one, work done of body A. Force of body A, yun mismo yung tension na nakakabit mismo kay body A. At yung body A natin, yung tension doon is twice the value of T. Distance of body A, hindi natin alam. Say that is SA. No. Plus, force of body B, yun yung tension mismo na nakakabit kay body B. And that is tension T only. Multiplied by distance of body B, hindi rin natin alam, that is SB. Equivalent to 0. Now, analyze natin yung motion. 300 pounds to 200 pounds. Tama? Po pwede nating i-assume na since mas mabigat to, po pwede nating i-assume na yung motion is going downward. If this is going downward, tendency nun, going upward yung body B natin. No, or vice versa. Kapag inassume nyo to na pataas, eto dapat pababa. Bakit inassume natin? Dahil wala naman sinabi sa problem kung ano yung motion ng ating system. Gets po? Now, gagalaw si body B ng pataas. Therefore, yung distance traveled niya is positive. Yung body A gagalaw ng pababa. Therefore, yung distance traveled niya is a negative value. No? So, if we will divide both sides by tension T, cancelled na yan. Ito magiging 2SA plus SB equivalent to 0. Therefore, lipat mo yan, you can say that distance traveled of body B is twice distance traveled of body A. Gets po? Yan yung kinematic relation natin na tinatawag. For the distance. Ngayon, ito, kapag dinerive natin both side with respect to time, magiging ds over dt. And ds over dt is velocity. Tama? Therefore, we can say that velocity of body B is equivalent to twice velocity of body A. At yung velocity na yan, kapag dinerive natin ulit with respect to time, magiging dv over dt. No, and dv over dt is acceleration. Therefore, we can say that acceleration of body B is twice acceleration of body A. Yan na yung tinatawag nating kinematic relations between these two bodies. So ngayon po pwede na tayong mag-free body diagram sa bawat body na kino-consider. First one, free body diagram of body A. No, assume natin ito yung body A natin. Ano yung mga forces na nag-a-act dyan? Meron tayong weight. And the weight is equivalent to 300 pounds. Meron tayong tension dyan. Pataas naman, that is 2T. Ilan yung mga force na nag-act dyan, di ba? Wala na. Therefore, we can now use equations of motion. Taking summation of force along y equivalent to 0. Motion, inassume natin na downward. Therefore, downward forces ay positive. No? And 300 ay positive dahil downward siya. 2t is negative dahil pataas. Mali pala tayo dito. This is not equivalent to 0 dahil vertically nandun yung ating motion. That should be reverse effective force equivalent to WA over G. So, equal yan kay WA over G. No? So, substituting etong negative 2t, lipat natin dito, maging positive 2t, plus W is 300, acceleration, that is acceleration of body A, over G, that is 32.2. No, natira lang dito side na to is positive 300. And let this be our equation number 1. No, now analyze the free body diagram of body B. No. Assuming this is body B, ano yung mga forces na nag-act dito kay body B? Meron tayong weight. Weight is going downward 200 pounds. And then meron tayong tension dyan, pataas. Yung tension kay body B is tension T only. And then, wala na. Yan lang mismo yung force na nag-act dyan. No. Yung motion natin ay inassume natin pataas. Therefore, if we will take summation of forces along y, nandun yung motion natin, nandun yung reverse effective force. No? At yung mga pataas na forces ay positive. And then, tension T is positive. Minus 200 siya. Equivalent kay W. 200. Acceleration is acceleration of body B over G, 32.2. No? Combine natin yung mga unknown and then naka-equal lang yung mga constant. So, itong constant na to, lipat sa kabila magiging positive. Ito naman, lipat mo dito magiging minus. So, tension T is minus 200 multiplied by acceleration of body B with respect to body A, that is twice. No? Over 32.2. Ito, lipat mo, magiging positive 200 siya. No. Simplifying tension T minus 400, acceleration of body A over 32.2 equivalent kay 200. Equation number 2. Papasin nyo dyan, meron tayong dalawang equation, meron tayong dalawang unknown, tension T and acceleration of body A. That is 2 equations, 2 unknowns. So using your calculators, using mode 5.1, compute for the value of tension T and acceleration of body A. No. Mode 5.1, 2 equals 300 over 32.2 equals 300 equals 1 equals negative 400 over 32.2 equals 200 equals. Then mako-compute nyo na yung value ng tension T natin tsaka acceleration of A. Ano po yung value, guys?
163.64.
Sorry po.
163.64.
100 point 64. And that is pounds. Positive po ba or negative?
Positive po.
Positive. Therefore, pwedeng tama yung solution natin, no? Dahil positive yung tension natin. Kapag naging negative yung tension natin, mali yung ating solution. No? Dahil correct na yung assumption natin eh. Yung tension is, inassume na natin yung kanyang direction talaga. Which is, going away sa ating body. And then, acceleration of body A, ano na-compute po?
Negative 2.93.
2.93
3.
feet per second square. Tama?
Square.
Negative. Ito yung sinasabi kanina, guys, sa ating steps. No, yung dalawang body natin ay hindi siya in contact with a surface. Therefore, sa ating free body diagram, wala tayong kinonsider na friction force. No. So, kapag nakakuha ka mismo ng acceleration na negative yung value, yung magnitude value na 2.93, tama. Yung negative sign doon indicates na yung inassume yung direction ay mali. Ibig sabihin, ang body A dapat ay pataas, ang body B dapat siya ay pababa. No? Yun lang po indication. Kapag yung mga bodies natin dyan ay in contact with a given surface at yung acceleration nila ay nakuha nyo ay negative, ang ibig sabihin nun, discard your solution, mali yung magnitude na nakuha, mali yung direction na inassume. No? So dito, hindi siya in contact with the surface, walang friction force, tama yung magnitude, mali lang yung direction. Gets po? So ibig sabihin, that is positive 2.93 feet per second square, and body A should be going upward. So, hindi pala kaso yun. Hindi kaso na mas mabigat siya yung bababa. And then, tataas yung mas magaan. So, for this case, tataas mismo yung body A, bababa yung body B. No. Ang kinukuha sa problem, acceleration of body B. And we already know that acceleration of body B is twice acceleration of body A. No, therefore, acceleration of body B is twice of 2.93. That is equivalent to 5.86 feet per second square. And dapat ito ay going downward. Any questions po? Wala? Okay, pag walang tanong, iputulin muna po natin yung discussion natin at this part. We'll just continue the discussion next meeting.